Hey guys, I'm going to attempt to do a little review on here for your quiz tomorrow on arithmetic and geometric sequences, just because I know some of you would like the extra help. So, what I'm going to do is I'm going to switch you around, and then I'm just going to kind of talk to you and see if we can get you on the right page. So in order to be successful tomorrow on your quiz, what I need for you to know is that an arithmetic sequence is a sequence whose pattern is addition and subtraction. A geometric sequence is a sequence whose pattern is multiplication and division. Okay? If you are going to look at the picture of a line in the equations, the arithmetic ones represent linear functions and the geometric ones represent exponential functions. Okay? So you need to know two things for tomorrow, and that's how to define both of these recursively, can't spell, recursively, and explicitly. Okay, if you can do those two things, identify them recursive and explicit, you will be fine. So a recursive formula, remember that it says that it needs to use the previous term. Okay? The previous term has got to be a part of the formula, and that has to do with your f of n minus 1. That has to be somewhere in your formula. Explicit only deals with the nth one, so that way you can plug in whatever term number you are trying to find. Okay, so with an arithmetic sequence, a recursive rule is going to always start off with f of 1 equals. You're going to give your first term, and then you're going to say, okay, to get the nth term, or any term, you're going to take the previous one, which is n minus 1, and you're going to say that you're either going to add or subtract whatever you found the pattern to be, your difference. That's your pattern. If you're going to write a recursive rule for a geometric sequence, it's still going to start off f of 1 equals. With recursive, you have to give your reader a place to start. It's still going to say, okay, to get the nth term, I take the previous one, and this time your pattern's either going to be multiply or divide times your ratio. That's what they're going to look like recursively. If you want to write an explicit rule for your arithmetic sequences, the ones that have patterns of addition, subtraction, then what you're going to do is you're going to say, okay, well, we've got f of n. To find the nth term, you're going to take the first term, you're going to add your difference n minus 1 times. And all that means is you're going to add the difference one less time than the term number you're on. Okay? Now, if we look at an explicit rule for geometric functions, it's going to look similar. Okay, to find the nth term, you're going to take your first term, but this time you're going to multiply it by your ratio, and then the n minus 1 is in the exponent, because exponents tell us how many times to multiply something together. Okay, let's look at a couple examples. We're going to start off with a sequence and decide what it is. So let's look at 35, 32, 29, and 26. Okay, so the first thing that I notice when I look at this pattern is to get from one term to the next, it looks like I'm subtracting 3. Since the operation is subtraction, that means this is an arithmetic function. Okay? Now, let's look at the rules. I'm going to abbreviate here, and excuse my kids in the background. If you write a recursive rule, look at what we have up top. Okay, it says to take f of 1 equals, and it says my first term. So my first term is 35. And now we're going to write a rule that says, okay, to get the nth term, I'm going to take the previous one and subtract 3. That's your recursive rule. If I want to write it explicitly, we're going to follow what I wrote up top. Here, this one, f of n equals my first term, which is 35. The pattern is to subtract 3, and you're going to do that n minus 1 times. Okay, that's how you write this rule. Now, if I say, hey, let's find the 12th term, then what you're going to do is you're going to plug in 12, and you're going to say, okay, well, that's going to be 35 minus 3, and we're going to do that 12 minus 1 times. Well, 12 minus 1 says I'm going to do that 11 times. If we go ahead and solve this, it says 35 minus 33 is 2. So in this sequence, the 12th term would be 2. Okay, that's an example for arithmetic. Okay, what are we gonna do? We're not gonna flip the page. We're gonna try and fit one more on here. Let's look at another example. Okay, let's look at this in a different pattern. Let's look at 100, 50, 25, and 12.5. When you look at these, you should notice that each term is half of the one in front of it. So if you want to write a recursive rule for this, you're going to say, okay, f of 1 equals, that's my first term, so it's 100. And then to get any other term, you're going to tell me to take the previous term and multiply it by a half. You could also write this as divide by 2. It's whatever you choose, okay? They're both the same thing. Explicitly, so we're looking up here, it says, okay, take my first term of 100, multiply it by a half, but do that n minus 1 times. So let's say I want to find, what is 1, 2, 3, 4, let's just do the 5th term. That means I would say, okay, take 100 to do the 5th term. It's going to be 100 times 1/2 to the 5 minus 1. Okay, so that means 100 times 1/2 to the 4th, which means I'm going to take half of that, and if you compute that, it's going to be 6.25. So the 5th term is going to be 6.25. So those are 2 examples of how to write recursive and explicit for both an arithmetic, which is this one, and then geometric for the one that's in purple. Okay, now let's do one other thing, or maybe 2. Let's look at finding some missing terms. So if you're trying to find missing terms, okay, that means I've given you a list and there are things missing. I'm going to tell you whether or not it's arithmetic or geometric. So we're going to start with arithmetic, and let's look at this list. 16, blank and a blank, 7, and a blank. If it's arithmetic, that means that I either had to add or subtract to get this list of numbers, okay? The numbers got smaller, so that means I obviously had to subtract. So how many did I have to subtract? Well, to get from here to here, I had to subtract 9. Well, I had to subtract 9 once, twice, 3 times. So negative 9 over 3 tells me that I subtracted 3 every time. So to fill in, that's my difference. So to fill in the blanks, I just subtract 3. So 13, 10, 7, and 4. If it's geometric, it's going to look similar, but just a tad different, okay? Geometric, let's look at this one. We've got 1, blank, 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 16. Now, if it's geometric, that means my pattern was either multiplication or division. Well, my numbers got larger, which means I had to be multiplying. Okay, well that means, what do I multiply to get from 1 to 16? 1 second, honey. I multiply by 16. And then how many times did that happen? Once, twice, 3, and 4 times. So whatever number that I multiplied by, I had to multiply by it 4 times. So what we're asking ourselves is, what number do I multiply by itself 4 times and it give me 16? Well, that number should be 2. So if we just multiply by 2, we get 2, 4, 8, and 16. I hope this helps you guys. Make sure that you study and let me know what else you need.